Time starts now. Whether you get quiet or not, I don't care because I'll just stand up here for 13 minutes, eat the no, and let the time run out. So if everybody's not paying attention, then
Page number 21.
21. They give us shape, looks something like this. They tell us this is, does that say 12 centimeters? Is that right?
Yeah.
What else they tell us? They tell us something in here. That's what?
6.
6 centimeters. What do we have to find the area of this time?
Everything.
I know that. What? Tell me what they are.
The rectangle is.
Remember last time I said, and again, a whole bunch of you don't believe me, but what makes these easier?
Using your brain.
Use, write out the words first.
Rectangle
So
plus-
rectangle plus what?
Half square.
Half a,
No, you get 2 halves. That's a circle.
is that a whole circle then?
I don't see the other one.
It is, right?
It's not on there, but you can,
Okay.
it's just giving you the same thing on both sides, right? So that's, I just put it in there. So rectangle plus a circle, have your calculators out so you can help me here. What's the formula for area of a rectangle?
Base times the height.
Base times height, what is the base and the height?
1226.
I'm trying to hurry here, so if you guys aren't paying attention, then,
72.
so that's 72. Circle, what's the formula for area of a circle? Pi times radius squared. What's the radius this time?
6.
Which one is that? I heard 2 different answers. 3. It's half the distance, right? So do that on your calculator. How you what? This whole distance is how far? 6. So half of it for the circle would be 3. 28.3.
Huh?
Is that right?
I'm confused. What do you? I had the same Kellen. I had the same question as Kellen. How did you get?
Because the radius, say like the top from the to the middle is 3.
Oh,
and the
okay,
top from
okay,
the bottom
okay.
is 6.
I got you now.
I always look at it from side to side.
Wait, what is it called when it's the full
Diameter.
A circle.
What do we do with that?
They're together.
100.3.
Yeah.
What's our units?
Centimeter squared.
Centimeters squared. Everybody agree with that?
Sure.
Oh, they wanted the perimeter too, didn't they? My fault. So to find the perimeter, if I start walking here and walk to there, how far have I walked? 12 plus
12.
there, another 12, right? How am I going to find these 2 distances?
Would that be
It's the what for the circle?
pi times diameter?
It's pi times diameter, it's the circumference.
But half of the
So, do we want half of it this time?
No, because there's 2.
So this would be half, this would be half, so we want the whole circle, right? So diameter times pi, what is the diameter this time?
6.
Somebody type all that into your calculator. 12 plus 12 plus 6 pi. 18.8 total?
No, 42.8.
42.8.
42.8, what's our units? Squared this time?
No.
So if you walked all the way around that shape, how far would you walk?
42.8.
42.8 centimeters. Next question.
I didn't really get the front page done.
Can you?
That's what Google left the front page. Hence, I didn't do it.
Next one. 8. 8.
Is it open or close? Is that what that is? Ellipse, sorry.
Not cool.
Number 8.
Is that what it is?
There's no such thing as an oval.
Okay.
No. I got a question.
Yes.
So if there's no such thing as an oval, why didn't they learn us young at an ellipse?
Teach us young?
I have no
Teach
idea.
us, yeah.
I have no
One
idea.
way to say
There's
it.
like a lot of ways that
It's
like.
easier to say than ellipse.
I honestly didn't teach us anything.
And.
Probably easier to
same thing
spell.
Kellen just did, instead
I don't even
of
know
saying
how to
an
spell
ellipse,
ellipse.
he said something different.
I have a
Well, they tell us the length of this side is, Branson.
Two L's in
I just had to talk with you, man.
I know, it's actually a question. For number 4, is that like a square? Because I did have a square.
Yes.
Okay.
This side's 5.41. Does that, everybody agree with that, 5.41? What's this side?
7.67.
This whole side down here,
8.2.
and the height, 4.9. First, let's find the perimeter. I know, well, first, what shape is it?
It's
It's a triangle, so write triangle in there, that's the third blank. Triangle. I'm going backwards here. Perimeter, how do we find the perimeter?
Add up both sides.
What do you get? We're wasting a lot of time. Nobody can pick up their calculator, Ethan O, I guess. I guess I don't have to call you Ethan O, nobody.
21.28.
21.28, what's our units?
Yards.
Yards? Find the area, how do you find the area of a triangle? It's formula.
Base times height divided by 2.
Base times height divided by 2. What's the base this time?
8.2.
8.2. What's the height this time?
4.9.
Do that on your calculator.
20.09 yards squared.
Everybody agree with that? Next question.
11.
Which question, Ethan?
On number 8, the math doesn't add up on the sides.
What do you mean?
Like, if you do h squared plus c squared.
It
then
won't,
never.
because it's not a right triangle. Now, if you did it for this triangle on the right, that one would work. Because that is a right triangle. But the big triangle isn't a right triangle. Somebody help me out, tell me the numbers on this one. What's this side, or this height?
20.
Do we know this side?
No.
Do we know this whole bottom?
Yeah.
What's it?
33.
33. This side up here?
21.
21. This side over here?
16.
Yeah.
16. Do we know anything else, or is that it?
That's it.
That's it?
Yeah.
Do we have, I know, I drew mine and it looks sort of like a parallelogram. Does that mean it is a parallelogram? No, just the way I
Looks like
drew
a
it.
pyramid.
Alright, so it's not supposed to be, so do we have a formula for this shape? So how are we gonna find, the area of it?
You want to do each triangle?
Do each triangle?
Triangle.
I mean, you can do the big triangle and then the small triangle.
So if we try all 3 triangles, if I look at this triangle right here, what's the height of that triangle?
20.
20, what's the base?
We don't know.
We don't know, so we can't really do that, can we?
Other triangle, which is 33 times.
Does everybody see this triangle that Kellen's talking about? What's the height of it?
20.
20, what's the base?
33.
So 20 times 33 divided by 2, somebody tell me what that is.
330.
Anybody else get 330?
I didn't get.
So we've gotten this triangle. What do we still need to find the area of?
The other
The
triangle.
other one.
This other one up here, what's the base of it?
16.
16, what's the height of it?
21.
168.
168, everybody agree with that? What are you gonna do with those two?
Adam.
498.
What's our units?
Units squared, so it doesn't give us units.
Yeah, I told you,
Meters.
meters squared. Find the perimeter. What are we gonna do to find the perimeter?
Add all the sides.
Add up all the sides. The bad thing is that we don't know this one. We're gonna be able to find this one by the end of the year, but we skipped some stuff. We can't find it right now, so for perimeter, just put an X there. You can't find the perimeter on that one. Next question. Hurry, we got about 4 minutes left.
His angles are
You never,
With this camera. Just don't feel like giving them any answers. 7. Problem number 7. What kind of shape do we have in 7? Trapezoid, so that's the bottom blank. Then we want to find, for the second blank going up, we want to find the perimeter. How are we going to find the perimeter? Add up all the sides. Add up A1, A2, B1, and B2. Somebody add all those up for us. A1, A2, B1, B2. 30.9. What's our units?
Inches.
Somebody saying that they got something different.
Yeah, I got 25. I got 25.5.
Yeah, I got 25.
Did you add up every one of them?
Which one should we leave out? If they did add height.
I got 36.
Did you add
Oh, wait,
in?
I got 25.2 as well. Yeah, you're not supposed to add in the H.
Not supposed to add in the H, right? So try it again. What do we get?
25.5.
25.5, everybody agree with that? The H is the what? The height. Formula for area of a trapezoid.
Add up all.
Formula for area of a trapezoid.
Half the height times B1 times B2, or plus B2.
Remember we said to change it and make it like this? What is the height this time? 5.4 times, what's base 1? Be careful, don't,
6.2.
remember, base 1 this time is which letter on there? A1 and A2, right? I'm not sure why they put it that way, just to confuse you, I guess, but it's, the bases are the two parallel sides, all right? So what is A1? What is it, 9.4? What's A2? 4, just 4?
Yeah.
Do all that? Which question did we do? 36.20?
1.8.
Oh, 36.18, anybody else get that?
200.
Remember, what do you do first on this on your calculator?
Add that.
Do those, hit equals, then hit times, 5.4, hit equals, then divided by 2.
36.8
What's our units?
inches squared.
Next question.
I found the perimeter, I don't know what number is that.
Did-
I have a question.
Which question?
Why did we do A1 and A2 and this B1 and B2?
Because their letters don't correspond with our formula. You got, our formula, I should have written this. Height times base 1 plus base 2.
Oh, okay. So we did.
The two that are the bases are the two that are parallel to each other. So this one up here and this one down there. Why they lettered them that way, and I keep thinking that I'm gonna change it so it doesn't confuse everybody, but I stole this from somebody and they put A1, A2, B1, B2. Stupid. I don't know why they did that, just to confuse you, I guess. Next question.
Do you want to do 16?
16, last one, make sure your names are on these.
Is 16 or rectangle?
You pick one.
19's easier
Yeah.
than 16.
Okay, then let's do 16.
Well, they're both actually pretty easy.
Something like that, is that about right?
Yeah.
11 and 4, you just remember the units because I'm not writing them all down. 5, what's on bottom?
5.
5. So what's this side over here?
5.
5. What's this over here? 4.
How do we know the bottom?
How do we know these two?
Take 5 minus 11.
Take 5 close.
11
5
minus
minus
5.
11 minus 5, what's that give you?
6.
Now we know that they total up to 6. Do we know that each one's 3? Not necessarily. Do we care?
No.
No. Let's do perimeter first. How are we gonna find the perimeter?
Add them all up.
Add all those up plus the 6. 40. What's our units?
Centimeters.
Now let's do the area. I know it's backwards on your paper, but just switch them around. You're smart enough to do that, right? Area. Do we have a formula for area of a shape like this?
No. We do have one for a rectangle.
So let's split it into 2 rectangles. What's the area of this bottom rectangle? 25. I'm gonna write that in there. What's the area of this top rectangle?
44.
What are you gonna do with those two?
Add them together.
What do you end up with?
69.
What's our units?
Centimeters.
Make sure your names are on those. You're gonna lay them right here on this desk. If you didn't pick up the notes, go up there and get them.
Oh wait, I have really bad handwriting. I made it my 5 look like an 8.
Oh, I must have read my name on it. That would have been very bad.
You need to keep it like that.
Again, if you didn't grab the notes, grab them. Start filling in what you need to fill in on this first part. What we're going to cover, surface area and volume. We talked about surface area and volume a little bit earlier this year. We'll go a little more into detail.
That's my form. Damn.
With a prism.
Mr. Ebersole,
Yes.
I have a question.
Yes.
Can I turn that paper we just turned in like an intervention? I have a lot to fix on it.
Coming ham on that handwriting.
Let's go sit down. I'll get it to you. You forget. You're out of luck.
Okay.
With the prism. Looking at these shapes that I have on my desk here, remember, all prisms, you might want to write that down. All prisms are, instead of the shapes that we've been dealing with, all the shapes that we've dealt with up to this point were 2D. Prisms are 3D. So 3D shapes, that means they got 3 dimensions. Of these shapes that I have setting up here, which one is not a prism?
The hexagon looking one.
This one?
Hexagonal prism.
Is that a prism?
Yeah.
Well, I guess.
Luke just answered his own question, didn't he? Because what do you call it?
Hexagonal.
A hexagonal prism. It's not actually a hexagonal prism.
Isn't that a cube?
All right, it's an octagonal prism, but right idea, right?
Isn't that a pyramid?
The pyramid. Is that a prism?
That's a pyramid.
No, it's a pyramid. All right. One other one up here that's not a prism.
Isn't that a cube?
Is the cube a prism?
No.
I guess, yeah.
Yeah.
Yeah, it is.
Yeah.
Alright? Is a cylinder a prism?
No.
It's a
Alright,
It's a
so
s-
pyramids,
tube.
cylinders, the other one that I don't have up here that we're gonna cover. What other shape is not a prism?
A cone.
A cone, then there's one other one I just seen when I was digging in my box.
A sphere.
A sphere is not a prism. All of these are not prisms. Alright, we're gonna cover them next time. We're gonna cover them next time. They're not prisms. Everything else, all these are prisms. The way you can tell something is a prism, it's always gonna have two bases. Listen closely. They have to be exactly the same as each other, and they're parallel to each other. Right? So when I'm looking at this shape,
It's got.
is this the base down here? No. What's the base?
The top and
The
bottom.
two triangles are the bases. No matter where they're sitting at, those are the bases. Because they're parallel to each other and they're exactly the same. Does everybody understand that?
So that would have
Alright? So on this one, which face is the base?
all of them.
It could be any of them. It doesn't matter. If I have a rectangular prism, which face is the base?
All of them.
It could be any of the two, right? So maybe if I'm holding it this way and Michael wants to say, well, the base is always the bottom. For a rectangular prism, that works out. That's a base. That's a base. All right? All of the other faces are called lateral faces. And they always have to be what shape?
The same.
Rectangles.
Oh, well, okay.
They're always rectangles. So if I'm looking at this,
Oh, yeah.
and this might have been the one that maybe Luke was looking at, because this is a hexagonal prism.
I was looking at that.
All right? Yeah, that's a hexagonal prism up there. So this is a hexagonal prism. Which faces are the bases?
The hexagons.
The hexagons, and all the rest of the faces are what shapes?
Rectangles.
Rectangles. Now the ones that we deal with, all of these rectangles, guess what's going to be true about them?
They're equal.
They're all going to be equal to each other. Right? For most of them. Now, does that mean it has to be that way? No. Again, we go back to our cube here. Cube is a rectangular prism because all squares are what shape?
Rectangles.
Rectangles. Alright, so all these faces, even though they're not considered the bases, are still rectangles. So, all of your faces, when you're looking at any kind of prism, you're going to have two bases and then a whole bunch of different rectangles, whatever they are. Again, the rectangles are called the lateral faces. This is important because in the real world, if I'm doing something like building a barn, what shape is the actual structure of the barn? A rectangular prism, right? So the barn's a rectangular prism, but it doesn't have a what? A bottom or a top. Those are different things, aren't they? So the lateral faces are the sides of the barn. The bases are the top and the bottom, which it doesn't have because it's different. All right?
What if I build a triangular barn?
Build a triangular barn, then is that possible? Yeah, sure. So if you got a triangular barn, might be something that sort of
Well, I can have house.
looks like that.
Use some Abraham house. That'd be cute.
Yeah, mine looks terrible, but looks something like that.
What the?
But still, we're looking at it. Now our bases are the two triangles, right?
Mm-hmm.
And the other faces are rectangles. What are we not going to have in that?
A floor?
The floor, all right? Maybe it's just dirt or whatever, so we don't have that floor. That's why we deal with lateral faces and the bases, because sometimes we need to know, hey, in this formula that we're going to use, we're going to get rid of some of these things. In the real world, it's not just going to look like Ethan's barn's not just going to look like this. and have all these spaces on it, because that floor's not gonna be there.
What if you?
Alright, now you put, if you build a floor, then that might be something that you have to take into consideration, right? So if you're building a house, you got your footers around the bottom of the house, but then you build a floor over top of that, right?
Yeah.
So when you're building all that, then you need to take that into consideration, and you have to know that. Again, what are you not gonna have though?
Like top.
The ceiling maybe, because it may be gonna be drywall or whatever else, and so it's not solid like everything else. The one that I use all the time, if you have a cup,
Okay, a
right?
cup,
If you have a cup, what does it not have?
I see it.
a top.
It doesn't have a top on it. If it was all solid, you couldn't put anything into it.
Ceiling?
A pool.
It don't have.
If you build a rectangular pool, what does it not have?
A rectangle at the top.
It doesn't have the rectangle at the top.
Because if it did, it'd be a well.
Right. Wouldn't be a pool then, it'd be a cistern or something.
What is a cistern?
Cistern, something that holds water. It's like a,
Okay.
Like a
You know, on the outside, you have
I-
that big cement pad, underneath that is a cistern pad.
Oh, that makes sense.
I didn't wanna say well because it wouldn't be a well, because wells don't have walls and everything else, you just drill down in the ground and the water's flowing in there.
Mm-hmm.
So a cistern, where the water is held there, it's like a tank.
Are we, do we have to draw these again?
Yep. You don't have to draw them again, they're right there.
Talking about.
Oh, on the homework?
nets.
Yeah, yeah.
Yeah.
It's a packet though.
Just don't do it like some of the rest of them, Kel, because they're gonna find out here real soon that I got about 25 people who are failing this class right now.
That's scary, I gotta check
And
my
this
grade
class,
now.
that'd be 26, cause I'm not here.
I'm like a 90 in here.
Yeah, you might not.
You should recheck that, buddy.
Have you graded everything so far? Put them in?
Yeah, I gotta get it all into Moodle, that's the part I've just been slacking because,
Probably not
So
gonna
I have realistically no clue what my grade's at.
Hey, can I use
That
something?
doesn't help me.
No, John, you're not allowed.
no,
Shucks.
That's kinda really scary. My grade go way
A
down.
net.
on a
The
net,
only thing-
what a net is, and we're gonna use nets, sort of nets, to do surface areas. A net is you take a three-dimensional shape, so I have this three-dimensional shape here, and I separate it and lay it out like this. Now, when we draw our nets, Cameron, I'm not worried about you drawing it perfect like this,
That's really good.
all right?
How'd you draw that?
What I'm worried about is the fact that if we do this, you know how to find the surface area of each, or the total of all these spaces. Alright, so we'll talk about that when we do a couple of these problems. Anybody have any idea what this is the net of?
A prism. A
Pyramid?
prism.
A triangular
Pyramid.
Pyramid, bro.
A pyramid, what kind of pyramid?
A rectangular pyramid.
A rectangular or square pyramid, because that's what the base is. We're not talking about those today. Anybody have any idea what this is the net of?
Rectangle.
Rectangular prism.
Single.
Alright, if I do this and fold it all up, it's a rectangular prism.
Yeah.
How about this one? Anybody have any idea what this one is?
Triangular
prism. A triangular prism. This is Ethan's barn, right? So if I fold it up and it looks like that, it's a triangular prism. Ethan would have the door, it would snap down like that.
Dude, that would be like the
Over
back
a moat.
cave. The back cave.
Over a moat.
I have a lava motor.
Anybody have any idea
Rectangular
what kind
prism.
of,
Hexagonal prism.
is that
No.
hexagonal?
One,
Hexagonal.
yeah, hexagonal prism.
Hexagonal prism, so if I fold this up,
That's like when they fight in the octagon.
hexagonal prism.
No, wait, that's.
No, that'd be a side.
Should, so like,
They don't fight
is
anything.
the octagon,
Fight
if they
an
don't
octagon.
do a prism?
Yeah.
There's 8 sides, so you won't get
No,
trapped
but,
in a
what
corner.
do you mean?
Like the octagon?
Oh,
the
yeah,
boxing?
yeah.
Mr. Ebersole, is that clockwork?
Boxing?
Yeah,
It's
it's
a
got
ring,
that
son.
ring.
You know what I meant? Like UFC.
Anybody have any idea what this is the,
Rectangular
Rectangular
prism?
prism?
a rectangular prism would work?
Prism?
A cube would work?
That clock is almost correct.
That one, we already did one like that.
Almost.
Someone saw it. Anybody have any idea what this would be? Even
A
though we're not
cylinder.
talking about today.
Couple
Division.
minutes.
This would be a cylinder.
Dude, who just screamed division?
15.
This
What'd you
would be a
say?
cylinder.
Division.
So, what we're gonna do, you gotta know which ones are the lateral faces, those are all not the bases, and which ones you need to be able to find the surface area. Main thing that we didn't do the first, when we covered this the first time, a lot of times, if we're building this, if this is our barn, and we're putting plywood over all of it, except for where we're not gonna put plywood.
On the bottom.
On the very bottom here, so we need to get rid of that, alright, and somehow we gotta do that.
Right there at the top.
Track the face.
We'd have to subtract off that face to find it. Fill in what you need to fill in on this. These are the formulas for surface area.
Okay, that line is.
Yeah, draw it in. It wouldn't let me change the picture.
Area of each face.
Out in the hallway. For a rectangular prism, to find the surface area, it's that formula. I would never, ever, ever use that formula. Alright? Just for the simple reason that most rectangular prisms in the real world, you're not going to find the area of all the faces and add them all together because there's going to be a face missing here or there. Like a swimming pool. We know a swimming pool doesn't have a what?
Face.
Doesn't have the top on it, right? If it does, it's not a swimming pool anymore. So you're going to be getting rid of one of those. And that's what the second part says. I would, on that second part where it's got the asterisk, I would circle it or something. You're going to find the area of each face and then just add them all up. That's going to give you the surface area of the prism, whatever prism we're dealing with. The other ones that I have down there at the bottom, those are just two formulas, and I meant to change those. Instead of writing them the way I have them written there, what's a better way to write area of a triangle?
Base times height all over 2.
So write it that way, base times height divided by 2, that's for a triangle. How about for a polygon? What's a better way to write it?
PA over 2.
P times A divided by 2. What's P stand for again?
Perimeter.
Perimeter. What's A stand for? Now be careful.
No, that's little a. That's what little a is.
So words you can't pronounce probably. The apothem.
Apothem.
I mean, what is an apothem?
Remember the apothem, if I draw.
Sounds like something that's in baby food. No, it's apricot.
What is?
An apothem goes from the center of the shape to the edge. You guys don't quit screwing around, I'm telling you what. There's a quiz up there that we gotta take, there's a test that I have ran off. We can do both of them today. And I apologize to those of you who are gonna have to do it because you got 3 or 4 goofballs in here, but. So the apothem goes from the center of the shape to the midpoint of one of the sides.
Like the radius.
It's like, see, I don't want to say radius, because the radius actually goes from the center to
The middle.
the corner.
Oh.
goes to one of the corners. That's a radius. The apothem goes to the midpoint of one of the sides.
One of the sides.
Yeah, any of the sides.
Well, that's an irregular,
Right, and all of our shapes have to be regular or we can't do any of this stuff. Because we don't have a formula for, if I draw that shape, we don't have a formula to find the area of that shape. The only way that we can find the area of that irregular shape is to split it off into like triangles. And then maybe we can find the area of each of those triangles and add them all up.
But if it's a prism, can't you do it if it's irregular? Because you just find all the faces, right?
The epithet goes to the
I mean, it's
midpoint
the
of the
same, right?
sides. So,
Like if I draw. what is it?
It's like-
If I draw
it's like
something that's
perimeter-
irregular,
no,
I still just find all the
it's
faces.
like radius, but radius goes to a corner. Do you see that pentagon?
Yeah, if
That goes
you
to
know
corner
enough
right
of the
there.
measurements, yes.
And epithet just goes to the middle of the sides.
So if you know enough measurements, then yes, that would work.
The measure,
Okay.
the base, yeah.
Yeah.
It's basically half.
Kind of, but like half the height of that certain segment.
What are you asking, Branson?
I don't
About the
understand.
epithet.
Like, how do you get that?
They're gonna tell you the apothem.
Oh, okay.
But an apothem, whatever shape you have, whether it's a, let's go back a slide here. If I go back to this, you see how we have that pentagon right there?
Yeah.
The apothem is always gonna go from the center of the pentagon to one of the edges. It's gonna form a right angle, and it's gonna split that side into two equal parts. So it always has to go to the midpoint. So that could be the apothem of that pentagon. The apothem could also come over here to this one, so on, so on, so on. It could go to any of them, but that's the apothem.
And
Right?
that's,
If we have let's say we have a hexagon, and my hexagon doesn't look regular, it has to be regular for this to work. The apothem goes from here to there, splits that up equally, so that right there is the apothem. Another thing that we haven't done anything with yet, but we will, is if you go from the center to a corner, that's called a radius of the polygon, just like the radius of a circle.
Okay.
So those are two completely different things.
I thought that the radius stayed the same length all the way around. How could that even be possible? for
It
a
does,
hexagon?
because if I go from there to the corner, and I go from there to the corner, and I go from here to that corner, what should be true about all those distances?
Oh, okay.
They're all gonna end up being equal.
That makes sense.
Now, it's not equal with this distance.
Yeah, that's,
Alright, and if I do this, if I actually try to draw it sorta, so it looks sorta right. And then let me erase there. If I draw it try to draw it so it looks sorta right, or correct, like it is actually regular. Yeah, it's not great.
it's pretty good.
If I take that center point and I draw it down to here, I draw it down to here, we know that these two segments are congruent. If I draw in a radius, what kind of triangle do we have right
The
there?
right triangle.
A right triangle, and we can use a squared plus b squared equals c squared. And if I know that this is a regular hexagon, 99.9% of the time, the thing that they're gonna tell you about on a regular hexagon is the length of a side.
Side, okay.
So if we make this side, let's say we make it 10 centimeters.
that whole thing's
So
So-
that means this is 10 centimeters, so what's this part right here?
5.
centimeters.
And then they tell us the apothem, maybe they tell us the apothem is 7. I don't know, just making up something. Could we find that radius?
Yeah.
Yeah. And one of the formulas that you have on your formulas chart, or on your formulas packet that I gave you, is using the radius instead of the apothem, because sometimes it's easier to use that. But that doesn't affect what we're doing right now. So all we're gonna do on each one of these, whatever the shape is, if I'm doing this shape right here, my rectangular prism, and I'm finding the surface area, I'm gonna find the area of this face, this face, this face, this face, this face, and this face. Wind. Kellen was complaining a little while ago about having to draw the net. I don't care if you draw the net perfect like it is. If I'm looking at this, the way I want to draw my net is I'm going to look at it and I'm going to say, okay, I got this base and something like that. That one's something like that. So I got those two, they're exactly the same. Then I got these two, the front and the back here, that are exactly the same. Then I got these two that are exactly the same. How many faces should a rectangular prism have?
A rectangular
Six.
Six. So I'm looking at that and I'm going to find the area of this one, write it in there, area of this one, write it in, area of this one, write it in, so on and so on. All I need on every one of these is what's the formula for area of this shape? Length times width, or base times height. I find the area of all of them, and to find the total surface area, what am I going to do with them all? Add them all up. All right? Now, once I do that, maybe this shape is a box, and we're putting stuff in the box, so it doesn't have a what on it? A top. So maybe we need to get rid of one of those. Is it hard to get rid of one of those?
No.
So just get rid of the one that you don't have, and then add up all the rest of them. Volume. Dealing with volume. Fill in what you need to fill in on this. Is volume the same thing as surface area?
No.
What's volume talking about?
How much can go inside?
How much will fit inside this? Surface area was talking about how much plastic it took to make it. Now we're talking about how much will go inside of it.
I didn't think this was so much easier.
Surface, oh, volume is, yeah, volume usually is.
She got like 3 spaces.
On some shapes, not on all shapes.
The shapes of that.
'Cause most everything you guys dealt with is a rectangular prism.
More like,
That's basically all you do. Volume. With volume, volume is always in cubic units. So you got to remember, when you're finding surface area, that's still units squared, just like any other area. If it says area, it's square units. If it's volume, your answer is always going to be in units cubed to the third power. So make sure you don't get those mixed up. And if we're dealing with perimeter, it's just in regular units.
Okay.
For a rectangular prism, the one that we use the most, that's the formula. Length times width times height. To find the length, the width, and the height of a rectangular prism. I don't like that rectangular prism. See if I can't find a different one.
Dang, mister.
So, this doesn't do much better. So if I have this rectangular prism, when I want to find the length, the width, and the height, I pick one corner. And does everybody see how 3 segments come together to make that one corner?
Yeah.
So that's why I have this dot here. I pick that corner, you got that, and you got that, all come together. One of them is your length, one of them's your width, one of them's your height.
So
It doesn't matter which one. All right? So one of these, let's say that one, we'll call it the length. We'll call this one the width. We'll call this one the height. It makes no difference. Mason, maybe he didn't like that corner I picked. He comes over here and he picks this corner. That might be his length. That's his width. That's his height. You pick one corner, and the 3 numbers that come together is going to give you your length, width, and height. It doesn't matter which one you pick to be what. So Riley picks this to be his length, and Michael picks this to be his width. Do we care?
No.
It makes no difference.
because it depends on how you're looking at it.
All right? So if it's standing this way, that way, whatever, it makes no difference which one's length, which one's width, and which one's height.
What do you mean don't confuse the B?
On this, you might want to circle this. Any other prism that's not a rectangular prism. So we've already talked about this shape. What shape was this again? Hexagonal prism. When you go to find the surface area of, or I'm sorry, the volume of this, not surface area. When you go to find the volume of this is where it gets harder, because we didn't do this the first time. When you go to find the volume of this, Branson, you with us?
Yeah.
You better listen, because I'm not explaining this 10 times. You go to find the volume of this. What you got to do is you got to find the area of a base. What shape is the base on this shape? The hexagon. So we got to find that area, and then we multiply it by the height.
There's like,
Where's the height at? Is that here?
no.
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 The height, and we might want to write this down here. You might want to write it in your notes. The height is the length that connects the two bases. So in this, where's the height at?
The rectangle, right there.
No, yeah.
It's that from there to there. Does everybody understand that? No matter how I hold this, that edge right there is the height. Does that make sense, Hannah?
Okay, that's.
So it connects the two bases. So if I'm looking here, if I have my triangular prism, is the height right here? That's the height of the triangle, isn't it? But
So-
that's not the height of the prism. The height of the prism goes from one base to the other. So you got to be really, really careful, and that's what I said. Don't get the B's confused. When we're talking about the big B, that's the area of that triangle. The big B is the total area of that triangle. When we have the formula for area of a triangle where it's B times H divided by 2, that's a little b. That's the base of just the triangle. So don't get big B and little b confused. And don't get the height of the triangle. Does everybody see that? I didn't know if I drew one. Does everybody see that on that triangle? That's the height of that triangle, right? Is that the height of the prism?
No.
So the height of the triangle is different than the height of the prism. Don't get those two confused either.
On the base, is it just the whole area of the base?
Right. So when it's big B, it's the whole area of that. So you just you find the area of that shape right there, and then you multiply it by the height of the entire prism.
So the little b, what do you take?
The little b would be the base of the triangle. When we're just looking at that two-dimensional shape, so we're just looking at that base to
Okay.
start us off. We're taking little b times h divided it by 2. That's telling us the area of that triangle.
Okay.
And then we take that answer and we multiply it by the height of the entire prism.
Because isn't there like a bunch of triangles in a line that forms that, like technically?
That's sort of what it's saying. So let's do if I do this box. I don't have an empty box laying here. Let's just do a book. If I do this book and we're trying to find the volume of it, right? This is a rectangular prism, correct? And I'm trying to find the volume of it. Well, as I look at each page is what shape? A rectangle. And what we're finding is how many of those rectangles it takes to fill up that whole rectangular prism. 400. So if we're looking at this, we're saying when we have this, how many of these hexagons does it take to fill this all the way up from the bottom to the top there? And again, I probably shouldn't say bottom to top, because does it really matter which one's the bottom and which one's the top?
No.
No, it makes no difference. From one base to the other base. So you gotta make sure, that's gonna be the hardest part, is knowing when you're doing any other kind of prism, you're doing volume equals the area This right here is the area of one of the bases times the height of the entire prism. And especially when it's a triangular prism, when it's Ethan's barn, then it really gets confusing because you got a height of the triangle and you got a height of the entire prism. You got a base of the triangle and you have a base of the entire prism. So really, really confusing. Fill in what you need to fill in on this. It's basically the same thing. I think there's one other, make sure you don't miss the little blank down there where it says big B. Just going back over the same thing. We talked about that enough, didn't we? We don't need to go over it again. I stuck it on here twice just because I wanted to really emphasize it. Did I emphasize it enough?
Yes.
All the different shapes, let's circle the ones that are not, or no, I'll tell you what, let's circle the ones that are prisms. This one,
No.
Yes. Yes.
circled under paper.
Cuboid.
A cuboid.
Yeah.
Some books call this a cuboid, we call it a
Rectangular.
rectangular prism.
No.
Cylinder?
No.
Yes.
Yes.
No.
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 Yes.
No.
Yes, no, I heard both.
No.
No.
Because it doesn't have a.
Oh, no.
Yes.
So those are all the prisms that we're covering today. Now, are there other prisms? Yeah, I didn't draw an octagonal prism, a pentagonal prism, all the different ones, but all those. And then pyramids, cones, spheres, cylinders, we'll deal with next time.
How'd you find the area of a cylinder?
We're gonna talk about that next time.
Wouldn't you do the area of the circle and then times that by that height?
Now,
Radius.
what are you trying to find?
Area.
If you're trying to find the area, then you're trying to find how much it takes to make the cylinder. All right, so if I go back over here and I get my cylinder.
Volume.
Exactly. If I get my cylinder, you're saying, how would you find the area? Well, we want how much cardboard did it take to make that. So we're gonna find the area of a circle, another circle, and a
What about volume?
rectangle. Now, how would you find volume?
Find circle times height.
All right, so volume is then, just like we said on our book, you're finding how many of those pages it takes to fill it all up. This time we're figuring out how many what it takes to fill it up.
Circles.
The circles to fill it all the way up for that certain height. The other paper that you grab. We're going to do these together. Get your calculators out. Help me. The quicker we get through them, the better off for you. Is that number one, really?
Yes.
Yeah.
On number one, first thing we want to find the surface area. And I know I gave you some space on the other ones. I didn't give you as much. If we're going to find the surface area, then we got to separate this off into all the faces. What kind of faces do I have on this?
5
Pentagon. So one, how many pentagons?
2.
Two, that's one. What do we know about the two pentagons?
They're congruent.
They're exactly the same, they're congruent to each other. And then what's the other faces?
5
Rectangles.
Rectangles.
What's true about, let's see, let me make sure. What's true about all these rectangles? They're all the same this time, aren't they? My pen doesn't like drawing on that board for some reason, it's crazy. Let's do the rectangles first. What's the length of each rectangle? 12, everybody agree with that?
360. For all of them.
That's 12, that's supposed to be a 12. What's the height of each rectangle, or the length or the width? 6?
Yeah.
Doesn't like writing numbers. So 12 times 6, what's that?
No.
Well, 72.
72. So what's the area of this rectangle?
72.
72. What's the area of this one? 72. What's the area of this one? Area of this one?
72.
Area of this one?
72.
I think, that's 280.
Now, what do we have? What do we have here? What shape? Pentagon. Remember, formula for area of a pentagon is, oops, not that. P times A divided by 2. I'm going to quit writing on this because it's looking like I can't still know how to write.
Divided by 2.
What's the P stand for? Perimeter. Somebody help me out. What's the perimeter of this pentagon?
How-
60.
60? Does everybody agree with Ethan on
Yeah.
that? 60? So I was going to quit writing that loud, I guess. What's A stand for?
Area.
Be careful.
Apothem.
The apothem, right? How long is the apothem this time?
4.
4. What's 60 times 4?
240.
So what's the area of this pentagon?
240.
240? What's the area of this pentagon?
What? And we have to divide by 2?
Oh, we got to divide by 2, so it's not 240, is it? What is it?
120.
It's 120,
So it's 242.
and that's 120. Draw. What are we going to do with all those to find the surface area?
Add them all up.
Add them all up. Somebody do that.
600.
600? Everybody agree with that? 600. What's our units?
Inches.
Inches
Squared.
squared, because it's area, right? It's still, even though it's surface area, it's still area.
Well, right, you can mark them.
Yeah, because then
Wait, how did we get 600?
Whose volume?
they added all these 120 plus 120 plus 72 plus 72 plus 72 plus 72 plus 72.
Oh, I forgot a 72. I'm an
Did you?
idiot.
Alright. Volume. If we do surface area first, volume's sort of easy. Because volume, the formula is big B times H. Big B is the area of one of the bases. What is a base in this case? Which,
120.
which,
Pentagon.
the pentagon, right? And what's the area of that pentagon? 120. We just found that. So if we find the surface area, that's going to help us find the volume. And we just take 120. Now remember, the height is the distance from the one pentagon to the other pentagon.
To the other base.
So what's that?
6. I got 720.
720. What's our units?
Inches cubed.
Inches cubed. Good. Sorry if anybody watches this video because I am going to start writing in the pen.
Pleasure.
Oh no. It's gonna be rough.
Surface area. For the next one, what shapes do we have? What's one of the bases?
Trapezoid.
A trapezoid. So I'm going to draw a trapezoid here. The other one's trapezoid. They got to be exactly the same, right? Don't look at mine; they don't look the same, but we know that they're the same.
And then there's two squares.
2 squares, maybe squares. There's 2 that are sort of the same, right?
Rectangle.
Looks like that and that. This edge or this end down here and this end are the same.
And then a tiny rectangle and a big rectangle.
A smaller rectangle and a bigger rectangle, maybe. Is that all the faces? So it has 6 faces. Is that right?
I'd say so.
Let's look at the bottom first, because it's usually the easiest to pick out. Give me a length and a width on the bottom.
10 on the bottom.
10 and 4. What's the area of that?
40.
So write that in there. Let's do the top. Be careful. What's the dimensions on the top?
2 by 4.
2 by 4. Everybody agree with that? So what's the area of that? 8.
2 by
How about an end here?
4 by 6.
4 by 6. Everybody agree with that? Yes, no, maybe?
Yes.
What's 4
Yes.
times 6?
24.
What's the other one then down on the other end? 4 by 6, 24, same thing. Now we got to do the trapezoid.
Well, you just cut it into 2 triangles and a square.
We could, but that just makes it harder because we actually have a formula. Anybody remember the formula for area of a trapezoid?
Isn't it like base? Is it?
Area of the
Base
trapezoid is
1 plus
area.
base 2 times height times divided by 2.
So in our trapezoid, we'll call this base 1. How long is base 1?
2.
2. How long is base 2?
10.
10. So in here we're going to put in 2 and 10. What's the height of the trapezoid?
3.
3. Does everybody see that? Remember, height's always going to be given with that right angle right there. So do 2 plus 10, what is that?
12.
Times that by 3,
36.
and then divide that by 2. So what's the area of this one? 18. What's the area of this one?
18.
How are we going to find the total surface area?
Add them all up.
Add them all up.
132.
Anybody else get 132?
Yeah,
That
I
seems
did.
off to me.
I got it.
You got it?
I got 132.
132. What's our units?
Not millimeters squared.
Volume. How are we going to find the volume?
18 times.
Remember, one of the bases, we take one of the bases of the actual prism.
Perimeter.
Which face was the base?
The trapezoid.
The trapezoid, right? So we take that, the area of it, times the height, which is the distance from one trapezoid to the other.
18.
So 4.
So 4, so 18 times 4, what's that?
72.
72. Hold on now. 72 what?
Millimeters.
Millimeters cubed. Can the volume be less than the surface area?
Yeah.
It doesn't matter?
Wait, no, it can't.
Yeah, it can.
It can?
What?
Doesn't-
Over here, the
How
volume
does
is
that make
more.
sense?
Because it doesn't. It's not. It doesn't have anything to
Does
do
it
with
matter?
the
You
surface
couldn't
area.
have
It does not matter.
It's how many.
It doesn't make any difference whatsoever. So don't think that. Don't think that volume or surface area, one or the other, always has to be bigger. Right? Volume, if we make this shape and it's really, really small like this, is it going to hold a whole lot?
No.
No. But
Surface area.
the surface area would be
Bigger.
right. So if we're looking at this desk and we want to find the surface area of it, that's going to be quite a bit. But the volume of it, how much would fit inside, not a whole lot.
Okay.
Next one, I can't see the next one because the thing's in the way. Give me a second to move it. Oh no, don't do that. What kind of shape do we have here?
Rectangular prism.
Rectangular prism. So for surface area, what shapes do I need?
You need 2 squares.
2 squares? Maybe. I don't know that they're squares, but all right.
4
They're
rectangles.
not.
4 rectangles. Now, if I'm doing this, when I do a rectangular prism, guess what I draw every time?
6 squares.
6 squares. As long as I don't think in my mind that they're squares, if I think, hey, these are rectangles, that's all that matters. Let's do the bottom first. What's the dimensions on the bottom? What by what? 13 by 4. How about the top then?
13 by 4.
13 by 4. How about the left end? What's the dimensions down
7
there?
by 13.
7 by
13.
7 by 4.
What?
How about the
Oh,
right
we're
end?
talking about the bases.
How about the right end? 7 by 4. How about the front? 13 by 4. How about the back?
13 by
13 by 4. Is that right?
No, the back's
Something's
13
wrong.
by 7.
So it's not 13 by 4 on this, it's 13 by 7. What's the front then? 13 by
7.
7, right? What's the area of the top or the bottom, whichever one?
28.
28,
No, that one's 52.
52. What's this one then?
52.
52. This one?
28.
28. This one? 28. This one?
91.
91. This one? What are we gonna do with all those? Add them up.
342.
Anybody else get 342?
I got 420.
420?
I got 342.
342. Which one are we going with?
342.
342. What's our units?
Centimeter squared.
Oh, that's what. Okay.
What if I said this was a swimming pool?
Then you
We take off the one of the bases.
We take off the 13 by 4.
Take off one of the 13 by 4s. So what would we do to find
Subtract
the surface area?
52.
Just subtract that one off or not ever put it in there, right? Volume. How do we find the volume of a rectangular prism? We had a formula for this.
Length times width times height.
Length times width times height. Remember, that's the easy one. So if I look at this shape, if I pick a corner, let's pick that corner right there. What are the three distances that come together at that corner? 7,
13.
4, and 13. Somebody multiply all those for us. 364
Yeah, 364.
centimeters cubed. Everybody agree with that?
Yes. Moving on back.
We all right?
Yeah.
Next one, as soon as I find. What kind of shape do we have in number 4?
A rectangular prism. Well, a cube.
Rectangular prism
Or cube.
or cube. Either one, does it really matter which one we call it?
No.
No, as long as it is a cube. Are all the things the same?
Yeah.
Let's see if I can write it this time. So for surface area, we want, nope. For surface area, we want all these faces, but what do we know about all the faces?
They're all the same.
They're all the same. How many of them are there?
6.
6.
6 times 6 times 6.
So all we really have to do is one of them. What's the front face? What by what?
6 times 6. And then just multiply that by
What's that give you?
36.
So the area of that one is 36. What's all the area of all the rest of them? 36. So what's the total surface area?
216.
216. What's our
Feet
units?
squared.
Feet squared.
And the
Volume. What do we do?
6 times
Length
6
times
times
width.
We just do length. It's even though it's a cube,
Can we just do length times width times height?
it's still a rectangular prism, right? So it's
Yeah.
just length times width times height, which is just 6 times 6 times 6. What's that give you?
216.
216.
It's the same?
Yeah.
Yeah.
Is it always going to be the same like that for a cube?
Hey, it's
Probably,
it's
yeah.
cubed.
Everything's the same.
It's cubed.
Oh, it's cube. My fault.
Yeah.
I don't know. Let's try a different one then. If I draw another cube over here, let's see if that always works out. Maybe that's something that could make things shorter on you.
That was pretty good.
Give me a length, a width, and a height.
4.
4. Let's do something. Let's do something a little bigger.
39.
12 times 12, and then this will be 12. So
It'd be the same.
we got 6 faces. Each one is what?
12 times 12.
12 times 12. What's 12 times 12? 144. How many of those do we have?
Times,
6.
so 864.
864. That's our surface area, right?
Yeah.
We didn't give it. Let's do inches squared. Okay.
12 times 12. Oh, it's not the same.
12 times 12 times 12 for volume. What's that give you?
1,728.
1,728 inches cubed. Is it the same every time?
No.
No.
How come this one did come out the same?
Because it's 6.
Oh,
Because it was 6, and how many faces do you have?
Oh, there's
6.
6 faces. That's why it came out the same.
Ah.
Next
Ah.
one. Next one. We're gonna make sure we get through these two, at least. What kind of shape do I have here?
Hexagonal prism.
Hexagonal prism. So on this hexagonal prism, the bases are what shapes?
Hexagons.
Hexagons. Yeah, that's not it. Just drawing a pentagon. Does that look like a hexagon?
Yeah.
Do I need to draw the other hexagon? Because apparently I'm having trouble.
Yes, sir. Yes,
No, we get the point.
Times 2, right?
Yeah.
And then what's the other faces?
6 rectangles.
6 rectangles. What do we know about all those rectangles?
They're all equal, so times 6.
So we can just do that times 6 instead of drawing them all. Let's do the rectangles first. What's the length and the width of the rectangle?
10.
Can you guys see it on yours? I can't see it on mine up here.
Yeah. 21 and 10.
It's okay. It's 10 by what?
21.
21. Somebody multiply those. 210. We're gonna have how many of those? 6 of them. So, and then keep hold of that number. Then for this, For the hexagon, do we just use the same formula? For hexagon, what's the formula? P times A divided by 2. What's P stand for? Perimeter. What's the perimeter of it?
60.
60 times A stands for what? Apothem. What's the apothem this time?
3.66.
3.66.
219.6.
219.6,
Is that right? 219.6
Divided by 2.
divided by 2.
109.8.
109.8. Everybody agree with that? Yeah.
So you gotta multiply that by 2.
Multiply that times 2. Multiply this times 6. Add them all up. What do you get? 1369.8. Anybody else get that? Yes, no, maybe?
Yeah.
I thought I heard different answers.
I mean, 60 times
Is that right or not?
3.66
That's right.
divided by 2 times 6. So, what? I got 658.
I got, wait, what was the answer they got?
460.
Wait, 210
I got 1,600.
plus
You got what?
409
Oh, I didn't add. Yeah. Okay.
times 2. 1479.6.
14. How'd you get that? We got like 7 different answers now.
Did you add them all up?
1479?
1479.6.
So each hexagon.
1479 point what?
6
6. What's our units?
centimeters squared.
Centimeters squared. Again, probably what we should have done here, because what's confusing you guys is the fact that we
Yeah,
tried to
yeah,
do it
right.
that way, right? And just think of that. What's the area of this hexagon?
109.8.
109.8. What's the area of this rectangle?
210.
210. Next rectangle.
210.
210. Next one.
210.
210. Next one.
210.
Tried to make it shorter, but probably should we try to make it shorter?
No.
Apparently not. So do all that now, add all those up, what do you get?
We don't have the brain capacity.
How do you find the volume? Remember, volume is big B times,
Little, I don't know.
big B times height. What's the base? Remember, that's the area of the base. Which one was the base?
The hexagon.
The hexagon. What was the area of it?
109.9.
109 point what?
8.
8?
8.
That's what it says.
Times 21.
Times, what's the height? So from one base to the other,
21.
21.
2,305.8.
Anybody else get that? What's our units?
Centimeters cubed.
Ethan O up here is getting frustrated because he got that wrong answer a second ago. Ethan O, you want me to tell you what you did wrong?
I didn't have that.
You didn't add that 109.8 in. You had everything else right, just forgot that in one of the faces. So if it had been a hexagonal pool and we didn't want a top, you've been perfect. Next one. What are we gonna do on this one?
Split them.
Split them.
You gotta sort of split it up. On this one, let's do volume first. What, if I split it up like right here, what 2 shapes do I have?
2 rectangles.
2 rectangular prisms. And we're just gonna find the area, or the volume of each one, add them up. For the first one, for this one over here, it's just length times width times height. What's the length of this one on this side?
30.
30? What's the width?
7.
Which one is it? I heard 2 different answers.
9.
9? Now you gotta be careful. So if we pick one corner, if I pick this corner right here, that's 30, you told me that, right? That's 9. What's that? 7.
Oh, I see.
Now, Ethan said 7 is the width. Does it really matter which one's which?
No.
No, it makes no difference. Somebody multiply all those together for us.
1890.
1890, is that our answer?
No, because don't you have to add those
We gotta do the other one. So I pick one corner here. Length, width, height. What's
7,
this
19,
distance?
12.
7.
Yeah.
What's the other one?
19.
19. 12, everybody agree with those 3?
Yep.
What's that give you?
1,596.
1,596.
1596. What do you do with those two answers?
Add them up.
Add them together.
3486.
That's your what again?
Surface area.
Volume.
That's your volume. What's our
What?
units?
Oh.
Meters cubed.
Meters
It's
cubed.
like a mansion, isn't it? Is that a lot? Is that big?
That is,
That's pretty big.
it's a lot.
It's like LeBron James.
Now, if we're gonna, now when we got surface area, you gotta be real careful on this because can we just do the two rectangular prisms? Because some of those parts aren't on the surface, are they?
Find every single.
So we gotta find each one sort of separately. Let's do this little bottom part here first. What's the dimensions on it?
9 by 7.
9 by 7. Everybody agree with that? How about this one? Ooh,
That's 18
18
by 7.
by 7. How about this one?
Which one?
7 by 19.
7 by 19. How about this nose part out here?
That would be 7 by where that there.
7 by 12.
How many meters are in miles? I mean, not mile, kilometer.
1,000. Now, on this, we can't really see it, but there's a top here, right? What's the dimensions on that top?
On the, just like,
The top rectangle up
can
there.
you draw the line?
Would it be 19 plus 9?
What are you doing?
Oh, the very top. It'd
Yeah.
be,
How wide is it first? That's pretty easy. All of them. How wide have all of them been?
I don't know.
7
by
7.
7 by
That's the thickness of the entire thing, right?
the bottom.
7 by,
30.
No, 28.
that was 19, this was 9, so 28. How about the back side over here that we
7
don't
by
have?
30. 7 by 30.
30.
30 by 7. Did we get all of them?
Yeah.
Sure.
What two haven't we got?
The back rectangle of the long way.
We haven't got the two L faces yet, have we? We haven't got those two yet? Let's figure all these up. What's this one? Area of this one. Let's go, Herc, quick. 63. How about this one?
Hang on.
126.
126. How about this one? 84. How about this one?
133.
133. How about this one?
196.
196. How about this one?
210.
210. How are we gonna do the L shape, this front
Split 'em up.
face?
You gotta split it.
You're gonna have to split it, aren't you? So we'll do like that one.
That's 30 by 9.
So this is 30 by 9 over here on this side. What's 30 times 9? 270. And on this side, what's this?
That's
12 by 7?
12 by
7.
9.
19. What's 12 times 19? 228. So if I do the same thing on this other L, what's going to be the case? Same thing. What do you do with all those?
Add 'em up.
Add them all up. That's
How was there
surface
only
area.
one that was 9 by 7?
Probably because nobody
Because it's not uniform like a regular prism.
But if you split it like that, I thought that probably that base and that base would be the same.
It's true.
That would be true, but we just did the whole top all as one thing.
Oh, you didn't.
We didn't split it.
You did this. Okay.
Packet lay there next to Michael is your assignment. Make sure you grab it before you walk out. Make sure you grab the packet before you walk out.
Here, someone get one. Another one.